Morning to every one of you. We are here with a new chapter, real number, exercise 1.1, chapter number 1, NCERT. Okay, so let us start with the first question. So first question said, use Euclid division algorithm to find HCF of. Means we are going to use Euclid division algorithm to find the HCF of these numbers. Okay or not? So what is this Euclid algorithm methods we are going to learn now? Okay, so here it is given how much, 135 and 225, right? So first of all you have to select which one is the bigger one. So bigger one, of course, it is 225, so we'll write here 225, bigger one. These 225 you will be dividing by 135. As you can see here, 225 I have divided by 135. So how many times it will be going? It will be going one time. So I have written here 135. Now here in 225 will be equal to what? How many times it is going? 135 into how many times? 1. So into 1. What is the remainder we got? 90. So plus 90. I hope first step is clear. Now this 135 we will be dividing with this 90. As you can see, 90 and 35. 135. So we'll write here 135. Now 135 we are going to divide. So 135 divided by 90. How many times it will go? One time. So one time means 90. How much is the remainder? 45. So we'll write here 135 equal to how many times it has went? One time. So 90 into 1. Okay. Plus what is the remainder left? 45. Okay. Now with this 45 we will divide this 90. Okay. So we have written here 90, 45, and how many times it went? 2. So into 2, and what is the remainder we got? 0. So 0. So when the remainder comes 0, there itself we will stop. Okay, got it? So by dividing with 45 we got the remainder 0. So this 45 will be the LCM, or will be our HCF. So we have written, since 45 is equal to HCF of 90, 45, 135, 90, 225, 135, equal, we have written or not? Hence the required HCF is equal to 45. Okay, so basically in this method you remember one thing, that until unless you get the remainder 0, you have to go on dividing it. Okay, and when you get the remainder 0, by dividing with what you have got the remainder 0, that will be the HCF. By dividing with 45 we got the remainder what? 0. So 45 is our required HCF. Okay, now moving on to question number 2. Here it is 196 into 38220, right? So here bigger number is 3220, so we'll write 3220. So 38220 divide by, what is the smaller number? 196. So divide by 196. So it will be going by how much time? 196 into, if you multiply 196 and 195, you will get 38200. So in the first step itself we got the remainder 0 or not? So we have written here 38200 equal to 196 into how many times it went? 195 plus 0. So that means hence the required HCF is what? 196. Okay. Now moving on to the third questions. Okay, the third question, here it is. In the third question they are telling us to find the HCF of 8, 6, 7, 5 and 225. So here this is bigger number, so we'll write here 8, 6, 7 divided by 225. So it will be going how many times? 3 times you try. 3 5 is 15, 6, 1, 7 and then 6. So here 2, here it will be 9, here it will be 1, right? Sorry, here 15, 6, 7 and 6, 75. Okay, so here it will be 2, and this one it should come, how it is coming 0? Just a minute. Okay, so I think let me check the question once. Okay, Okay, so it is here 2 to 5. Okay, so if it will go okay, so this one it will be going by how many times? 3 times. So 3 5 is 15. Okay, and 3 5 is 15, 16, and 3 6. So it will be 2 0 2. Okay, so this one will be 7. So it will be 1. Okay, so it will be how? See here, 867 and 225. Which one is the bigger one? 867. So this 867 will be dividing by 225. So 255. So 255. How many times it is going? 3. 765. So when you subtract it, you will get 102. So how to write it? You will write here 867 equal to 255, that is 255. How many times we have divided? 3. Into 3, what is the remainder we got? 102. So plus 102. And next step, this one we will write here, and then it will be divided by 255. So 255, when you divide, it will be going 51 times. Okay, so it will be written as, so we will be writing as 255, 2 times it will be going, so 2402. So it will be 51. So how we will write again? We will be writing 225 equal to 102 into 2 plus remainder is how much? 51. Now this 51 we will again divide this 102. So how many times it will be going? It will be going 2 times. So 2 times when you are multiplying it, it is getting remainder is coming exactly 0. So this 51 into 2. So 102 equal to 51 into 2 plus remainder is 0. So what we will write here now? Since 51 is equal to HCF of 102, 51, 255, 102, and 867, 255. Therefore, the required HCF is equal to 51. So this is very simple questions. I hope all of you have understood it. Now you can take it down and we will switch to the question number 2. Okay. Now we are going to do question number 2 of exercise 1.1. So question number 2 says that show that any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integers. Okay, so let a be the any positive integer. We are assuming that a is what? A positive integer. We have assumed it. Okay, so what we are doing, by division algorithm with a and b, okay, equal to 6. Okay, fine or not? So we are assuming that a is any positive odd integer. Odd means what? You can say that it is 1, 7, 9, 3, 5. All these are odd, which are not divisible by 2. Okay, so by division of algorithm with a and b equal to 6, we are assuming that the maximum value here we are going to take, it is how much? 6. Okay, that is the remainder maximum we are going to take 6. Okay, so we have written, we have a equal to 6q plus r. Okay, this is the formula. Okay, what is this formula? I will tell you. Dividend is equal to divisor into quotient plus remainder, right or not? There is formula, so that formula only we are using here. Dividend is what? Our dividend is a. Okay, because we have considered a as any positive integer, and is equal to 6. Okay, so 6 into q plus r, where divisor is equal to what? 6. Our divisor equal to 6 plus r, that is the remainder, into q plus r. So we have written here q is equal to what? Quotient, r equal to what? Remainder, where remainder can be 0, 1, 2, 3 up to 5. Here it can be, it will be r the value, it will be equal to or greater than r but less than 6. Okay, so we have written here a is equal to, now r का value we will put from 0 to 1. So 6 cube plus 0, 6 cube plus 1, 6 cube plus 2, 6 cube plus 3, 6 cube plus 4, 6 cube plus 5. So these are the values of a. Now one thing you tell me here, 6 cube plus 0, that is 6 cube is what, even or not? So this one we are going to reject it. Then 6 cube plus 1, 6 cube plus 1, this is will be odd. 6 cube plus 2, this is even. So 6 cube plus 3, this is odd, and 6 cube plus 4, this is again even, this one is odd. So what we will write here, out of this 6 cube plus 0, 6 cube plus 2, 6 cube plus 4 are rejected because a is odd, because we want our a to be odd, because we have already assumed here a is any positive integer, odd integers. So now whatever things are left out, hence any odd integer of the form 6 cube plus 1, 6 cube plus 3 or 6 cube plus 5. So these are the required one. Okay, so this and this is our required odd integers. What is this is what they are asking us to show. Hope students. Okay, so we are back with the question number 3. In the question number 3, it is said an army contingent of 616 members is to march behind an army band of 32 members in a parade. Okay, the two groups are to march in the same number of coulombs. What is the maximum number of coulombs which they can march? So we will write, since we are doing algorithm, division algorithm, so we are going to use the same method here. So by division algorithm, we have how many armies are, how many contingents of, how many members are there? 616. And what is the band the member is how much? 32. So we will find out the HCF of this, and whatever HCF we will get, that will be the maximum number of coulombs. Okay, so 616. So 616, so we are divided by 32. 32. It will go 19 times 6, not 8. It will come. So it will we will write it 32 how many times? 19. So 32 into 19, what is the remainder we got? 8 plus 8. Next, this 32 we will divide by 8. So 32 will be written here, divide by 8. 32, 8 4 is the 32. So 8 into 4, and what is the remainder we got? 0. So 0. So therefore HCF of 616, 32 is equal to 8, and hence the maximum number of coulombs is equal to 8. Got it or not? So this is all about your question number 3. Now we are going to do question number 4. Okay, to do question number 4. Question number 4 is very important for your board exam, both for CBSE and NBSE. It is very important. Okay, all of you should remember this is important question. It comes generally, this chapter is for 3 marks, and this question sometimes they ask for 3 marks. Okay, so but it is easy. Let us try to understand. Okay, fine. So question is, use Euclid divisions lemma to show that the square of any positive integer is either in the form of m3m or 3m plus 1 for some integer m, where m is an integer. So what we have assumed here, let a be any positive integer. We have assumed it. Okay, by division algorithm with a and b. Okay, now how we will know? In the last questions we have taken that a and b equal to 6, because there it was given 6q, like that they have given or not, 6q plus 1, 6q plus 2, like that they have given. So that's why we are assuming a and b equal to 6. But here it is given what, 3m and 3m plus 1. So we are assuming that a and b will be 3. Okay, I hope you understood it. Now we have a is equal to 3q plus r. This is the formula. Okay, this is dividend equal to divisor into quotient plus remainder, where r ka value it will be what, not more than 3, where r equal to 0 1 2, that is r greater or equal to 0 but less than 3. Okay, now same thing as we have done, we are going to substitute one by one the value of r. A equal to 3q plus 0 when r is equal to 0, a equal to 3q plus 1 when r equal to 1, a equal to 3q plus 2 when r is equal to 2. Okay, Now what we are going to do, one by one we are going to square it, okay? Squaring both sides, okay? Now squaring both sides of equation 1, 2 and 3. Let's mark it equation 1, 2, 3, okay? So we are squaring both sides of equation 1, 2 and 3, okay? And at the same time we are taking common also, okay? So when we square this one, a square, so here it is only 3q only, so 3q square will be how much? 9q square. So from here we can write it as what? 3 into 3q square. 3 3s are 9, right? Okay, we have to write in this form, okay? 3 into integer form. Then next one, a square will be equal to what? 3q plus 1, so whole square. So we are using the formula a plus b the whole square. So 3q is what? 9q square, plus 1 square is 1 only, plus 2 into ab. So 2 into a is 1, b is 3. So 3 into, it will be like this, 3q plus 1 equal to a square plus b square plus 2ab, right? So a is how much? 3. So 3 square plus 1 square plus 2 into 1 into 3q, okay? So it will be 9q square plus 1, 2 into 3, 6q. It is like this. Directly I have written it, okay, students? So if you don't understand, you can see this one, okay? So we are getting what? 9q square plus 1 plus 6q, right? So here you can see that between this one and this one we can take something common, that is 3. 3 if I take common, then it will become what? 3q square plus here it will be what? 2q, and this one will be there plus 1. So here also you see 3 into integers or not? Plus 1. Here it is coming 3 into integer plus 1. This part is nothing but m. What it is said? Integers. So this is 3 into m, that is integer plus 1, okay? Next one, we are squaring both sides. So it will be square, when you will be squaring it, you will use the formula a plus b the whole square. A plus b the whole square, then it will come 9q square plus 12q plus 4. So here also we have taken the common 3, then 3q square plus, here it will be what? 3 if I have taken common, then 4q, and here we have 4, so we have written here 1. So 3 into 1 plus 1, so it will be 4, right? So here also you see 3 into m integer plus 1. So we have written, implies a square is equal to 3 into integer, this is the first one, or 3 into integer plus 1, second one, and third one, okay? 3 into integer plus 1. That means that is what they are asking us to prove, right? Hence a square is the form of 3m or 3m plus 1, where m is some integers. Okay students, this is very easy one, and try to practice more. Okay, this is very important questions for your board exam from this chapter, okay? Now let us go to the next questions now. Okay, so students, now we are going to do question number 5, the last question of this exercise. Okay, the question is like this: use the Euclid division lemma to show that the cube of any positive integer is in the form of 9m plus 1 or 9m plus 8. Okay, so here what we are going to do, first same way, question number 5, question number 4, question number 2, these are all same category of questions. Okay, so all of you remember, you have to deal with these questions same way. Okay, so here we'll write, let a be any positive integer. We have assumed it in all these questions here also. By division algorithm with a and b is equal to 3. We are taking it as a and b equal to how much? 3. Now we have a is equal to what? Our dividend is equal to quotient into divisor plus remainder. So a is our dividend, is equal to 3 is our divisor, quotient is q plus r. Okay, r is remainder. So where r ka value, it will vary from where to where, from 0, 1, 2 up. It can have the value, the r can have a value of 0, 1 and 2. So we have substituted one by one the value of r, a equal to 3q plus 0, so it will be becoming 3q. This one we are marking it as equation number 1. Next, a is equal to 3q plus 1. This one we marked it as equation number 2, and the third one is a equal to 3q plus 2. This one we have marked it as equation number 3. Now what we are doing, we are cubing both sides. Okay, now in this case what we are doing, we are cubing it both sides. So cubing both sides of equation 1, 2 and 3. So from 1, first we are cubing equation 1. So when you cube it, a cube is equal to 3q whole cube. Okay, so it will come to 27 cube, and here I can take, see here they are asking us to prove it in this form or not. So 9 we are trying to keep it outside, and m is nothing but integer. So 9, if you take common from here, what is left? 3 cube. Okay, done. Now from 2, so from 2, a cube and 3 cube plus 1 the whole cube. The formula is, remember student, this one the formula a plus b whole cube का formula is a cube plus b cube plus 3ab into a plus b. Okay, this is the formula we have used here. So a is what? 3. So 3 cube plus 1 cube plus 3 into 3 cube into 1 into 3 cube plus 1. So if you cube it, 27 cube, 1 cube is 1 only, then 3 into 3 9, and into 3 27 cube into cube is square plus 9 cube into 1, 9 cube plus 1. So here we can say 9 is common, so we have taken 9 common. What will be left? 3 cube plus 2 3 cube square plus cube plus 1. So these are the things we have done it. Okay, next from equation 3, again we are cubing it, equation 3, same formula we are using, this formula. When you use it, at last you will be getting 9 into 3 cube plus 6 cube square plus 4 cube plus 8. Okay, now which implies that a cube is equal to 9, this is 9 into integers, okay, or 9 into integers plus 1, 9 into integer plus 1. Okay, 9 into integer plus 1 here, 9 into integer plus 1, or here we can see 9 into integers. These are nothing but, we are considering it integers. Here this one also integers, and this one here it will be integers. Okay, so 9 into integer plus 8, so 9 into integer plus 8, and this is what they are asking us to prove. So hence a cube is of the form 9m plus 1, that is 9m into integer plus 1, or 9m plus 8, where m is some integers. So this is what they are asking us to prove. So dear students, today we have started chapter 1, real number, and this is our first lecture on these chapters. This is lecture number 20. So dear students, I request all of you that if you are new to the channel, don't forget to share, like and subscribe the channel, your mathematics channel, Kumar sir. Okay, got it? Okay, in the coming futures we are trying to upgrade ourselves. If need arises, definitely we will have doubt clearing online session, also live sessions for doubt clearing on this chapters which we have done. Chapter 2, chapter 12, chapter 13 and chapter 1 is started. So from the beginning you please watch the video properly, full video you watch it, so that you can understand what is the things which is being taught here. Okay, and keep watching the videos in your channel and keep learning mathematics in an easy way. And thank you for your support and cooperations. Thank you.